So today we're going to work through a problem using Coulomb's law. And I already wrote down the equation for Coulomb's law. So we have F electric equals Kc times Q1 times Q2 divided by R squared. And this equation is on page 564 in your book, so you should have this written down somewhere. So we have our F electric, that's just our electric force. Kc is going to be Coulomb's constant, and the value for that is also on page 564 in your book. Q stands for charge. So we're going to have the charge of our first object times the charge of our second object. And then R, as usual, is going to be the distance. So we have our distance squared. So if we get into this problem, we have an electron and a proton in a hydrogen atom are separated by a distance of about 5.3 times 10 to the negative 11th meters. Find the magnitude of the electric force that each particle exerts on the other. So when we start with what we know, the only number that they give us in this problem is the distance, so that would be r, and that is 5.3 times 10 to the negative 11th meters. And again, as usual, our distances need to be in meters. Since this one already is, we are good to go. Okay, we also always know our Coulomb constant. That's always the same number, and it's going to be 8.9875 times 10 to the ninth newtons times meters squared divided by, try that again, divided by coulombs squared. Okay, and then for our charges, if you look at page 560 in your book, we know what the charge of a proton and what the charge of a neutron are. Okay, so I'm going to say that my electron is my first object. That can be either one, so that's Q1. And the charge in electron is negative 1.60 times, oops, let's try that again too, times 10 to the negative 19th Coulomb. Okay, then my proton is going to be my second object then. And a proton is going to have the same charge, but this time it is positive. So we have 1.60 times 10 to the negative 19th coulombs. So now I should be able to plug everything into my equation. So my electric force is equal to 8.9875 times 10 to the ninth times my first charge. And since we are finding the magnitude of the electric force, okay, electric force is a vector, but since we're finding magnitude, we don't need to worry about the signs of our charges. Okay, the signs just tell us if it's attractive or repulsive. So since we find magnitude, I can ignore those. So I have 1.60 times 10 to the negative 19th times 1.60 times 10 to the negative 19th, because they're the same thing, so I'm just going to square that. And my R value was 5.3 times 10 to the negative 11, and that is also squared, because that's an equation. And then I just have to plug that in my calculator, and you should end up getting with sig figs 8.2 times 10 to the negative 8 newtons. Again, it's a force. All of our units cancel out, so we get newtons. Okay. And the only thing to keep in mind is that if you would have kept in this negative with our charge, so we would have had a negative here, right? The whole thing would have been negative. And what that would have told me is that that electric force is an attractive force. Since we have a negative and a positive, we know that would be an attractive force. So hopefully this helps, and hopefully you can do some problems on your own now.